Today, I will reveal how a stone block weighing 80 tons can cross a river and climb a mountain without the help of modern machinery. And in the end, we will see on a reduced scale a technique capable of decreasing friction by up to 50%. Despite living in the technological age, there are still mysteries from antiquity that remain without a clear answer. A notable example is the immense blocks weighing more than 100 tons that make up the walls of Sacsayhuamán in Peru. This impressive construction is formed by thousands of polygonal stones fitted together with such fine precision that they resemble laser cuts. To this day, there is no definitive explanation of how the known tools of South American peoples could have carved, transported and positioned these gigantic rocks. When we speak of authentic enigmas, we must also look at places that, in addition to being challenging, are still little explored by the general public. An intriguing case is Ollantaytambo, an ancient Inca center located in the Andes. Its agricultural terraces, arranged on steep slopes, already draw the attention of visitors from all over the world. But the greatest mystery lies in less popular details. At the top, there is a wall built with 6 granite blocks, each weighing around 50 tons and standing more than 3 meters high, all adjusted with an almost impossible precision to imagine. In addition, there are colossal stones of 30 to 40 tons scattered around the site, resembling ruins of an earlier stage of construction, either destroyed or interrupted in remote times. The singular shape of these pieces suggests that what we see today is only a fragment of an even more grandiose original structure, which was dismantled, reused, and restored over the centuries. And those 50-ton blocks are not the largest there. Among them is an even more impressive granite rock, weighing approximately 80 tons. Its size is so disproportionate that it can hardly be photographed in its entirety, since part of it remains covered by another stone of similar dimensions. The surrounding area is fenced off, preventing visitors from approaching, but in records taken from different angles, it is possible to get a better sense of the scale of this monolith. Although exact measurements are not known, it is estimated to be between 6 and 9 meters in length, a unique and monumental piece. There is also a curious detail that goes unnoticed by most. Along the route between the quarry and the mountaintop are the so-called tired stones, unfinished blocks abandoned along the way, as if the construction had been suddenly interrupted. Studies indicate that in Ollantaytambo, the granite did not come from the local soil, but from quarries located on the opposite side of the valley. This reddish-toned rock was denser, stronger, and more durable than the volcanic stone of the region. The route includes ancient slopes, paved stretches, and platforms that seem to indicate a staged method of transport. The blocks advanced little by little, with pauses to reinforce the ground, reposition rollers or sledges, and only then continue forward. This is precisely where the great question arises. How did ancient peoples manage to move and raise such enormous stones on the Andean slopes? The enigma deepens when the location of the quarry is discovered, a rocky peak about 1.5 kilometers above the point where the blocks are today, more than 3.5 kilometers in a straight line. This means they had to be extracted from a high place, brought down, and then lifted again to reach their current position. The choice of this specific material, however, was not random. The pink granite had low porosity, great mechanical resistance, and less wear under altitude conditions. Once polished, it acquired a glassy shine, and its reddish hue held strong symbolic value in Andean rituals. In regions subject to earthquakes, the choice of a material that better resists compression may have been as decisive as the aesthetic factor. The enormous stone blocks, ranging from 30 to 80 tons, were not there by chance. They were extracted from a steep mountain about 1.5 kilometers away. They then crossed a river precisely where today a line of fallen trees can be seen at the foot of the slope. From that point, these colossal rocks were somehow transported to the other side of the valley. And the journey did not end there. They still had to be hoisted hundreds of meters higher to the site where they remain to this day. It is unlikely that this natural obstacle was overcome against the landscape. It makes far more sense to imagine that the crossing took place in harmony with the environment. During dry seasons, when the river's flow decreased, it would have been possible to build containment berms, temporary diversion channels, and trails reinforced with compacted pebbles, creating shallow and stable passages. Rather than relying on a single fixed structure, the strategy likely involved two main approaches. On one hand, reinforcing the riverbed with riprap; on the other, building ramps of compacted earth, taking advantage of low water levels to allow the block to cross in 1 or 2 days. Little is said about these details, and perhaps you're hearing this for the first time. After all, the idea that these stones were simply pushed downhill seems flimsy. A block of that size, falling from a great height, would hardly survive intact. It would crack, split, or shatter. Furthermore, moving a monolith weighing dozens of tons just to let it tumble would already be a colossal challenge. The real secret did not lie in brute force, but in the control of friction. On trails of moistened earth or clay mixed with water, wooden sleds would slide with much less resistance. When combined with short rollers, rotated forward in succession, the friction decreased even further. Multiple ropes distributed the weight, while fan-like arrangements of cables fastened to the front of the block allowed for delicate directional adjustments. The greatest danger was not the mass itself, but acceleration, which is why stone chocks and wedges were inserted every few meters to prevent sudden shifts. Still, the question remains: how did blocks weighing between 50 and 80 tons manage to cross a river and climb uphill for hundreds of meters? To grasp the magnitude of this feat, those numbers must be translated into tangible references. We are talking about 80 tons, the equivalent of 80,000 kilograms. That means each stone weighs nearly twice as much as one of the most common commercial airplanes on the planet, an empty Boeing 737. Want something even more astonishing? Compare it to the M1A2 Abrams battle tank. Its latest version weighs around 73 tons, a colossus capable of crushing any obstacle as if it were paper. And even so, it is still lighter than a single stone from Ollantaytambo. To bring the comparison closer to everyday life, think of a Toyota Camry, one of the most popular cars in the United States, which weighs around 1,500 kilograms. Now imagine stacking 53 identical vehicles. That would be the approximate weight of just one of those monumental stones. We are talking about 80 metric tons, or approximately 176,000 pounds, an almost unbelievable figure when we consider that all of this was transported without modern machinery by ancient peoples. The most astonishing part is that despite the outrageous weight of this rock, its total surface area is not many times greater than that of an average car. This simple comparison already shows how dense granite is and how its mass defies our intuition. It is so compact that it becomes difficult for the human mind to fully grasp. Upon close inspection, one can see clear percussion marks on the stone. Thousands of blows with stone hammers, even harder pebbles, gradually chipping away at the surface. Then came the refinement. Friction with sand and water, wearing down micro-reliefs until two faces fit together like pieces of a puzzle. That joint, where not even a knife blade can pass, did not require sophisticated metal cutting tools, just patience, natural abrasives, and an ingenious mastery of geometry. And that in itself is impressive. The big question then is, why go to such lengths to obtain specific granite from distant quarries when volcanic rocks were readily available around Ollantaytambo and were used in other constructions? This choice suggests that the motivation was not purely aesthetic. It was not just about preferring a reddish hue to decorate a temple. Something deeper, symbolic or technical, justified the colossal effort to transport those unique stones. And if all of this already sounds intriguing, wait for the next detail, the most repeated explanation for how these megablocks were moved. The conventional theory speaks of ropes, pulleys, and tree trunks used as rollers. Many texts even mention eucalyptus, a tall, fast-growing tree that can reach over 30 meters in just 10 years. The problem is that eucalyptus did not exist in the ancient Andes. It was introduced to Peru only in the 19th century from Australia, and it only began to spread significantly starting in the 1970s, thanks to government reforestation programs. Therefore, its presence in Inca constructions is a historical impossibility. The closest native species would be the quenua, also referred to as quinoa in some local pronunciations. However, this tree rarely exceeds 4 meters in height, grows in a twisted manner with curved trunks, and is far from providing the long, straight cylinders that the transportation of megablocks would require. This, however, did not make the process unfeasible. It merely changed the strategy. Instead of giant rollers, massive sleds were used, sliding over reinforced tracks of stone and earth. When short wooden rollers were available, they were placed in front and continuously repositioned. For uphill movement, ramps and wide platforms were built with stone and compacted earth. After each step was conquered, the sled was secured with wedges, allowing the team to rest and adjust the ropes. This detailed logistics, made of small calculated steps, was what truly made the impossible possible. And when we look at the whole picture, the material choices, the abrasion techniques, the lack of suitable trees, the ingenuity in transportation, it becomes clear. Ollantaytambo is not just an archaeological site. It is a monumental enigma that continues to challenge our understanding to this day. Another particularly striking aspect of Ollantaytambo is the diversity of masonry styles. At least 3 distinct patterns can be identified there, yet the most widely accepted explanation in academic circles still insists on attributing the entire construction to a single people, building everything during the same period. To support this view, some suggest that the builders simply changed their working methods over the centuries. First handling megablocks, then, tired of the difficulty, shifting to smaller stones. Indeed, in several Andean sites, it is common to observe distinct historical layers. An initial core of megaliths with structural functions, followed by more regular additions from the imperial period, and finally later repairs, often made after collapses, using smaller stones found nearby. This does not confirm the idea of a single hand behind the construction. On the contrary, it points to repeated maintenance carried out generation after generation. In a region where earthquakes are frequent, returning to the same site centuries later to reinforce walls, realign blocks, repair damage, and reuse what remained was part of the structure's life cycle. Even so, this explanation is considered weak by many researchers. The differences in technique are far too significant to be justified merely by convenience or laziness. Another controversial point is the hypothesis that the structure was never destroyed, but merely left unfinished. Field evidence tells a different story. Large rocks lie at the foot of the mountain, as if they had fallen from considerable heights. This strongly suggests a destructive event, likely caused by a major earthquake, a very common phenomenon in the Andes. In fact, the Andes teach people to build with tremors in mind, slightly inclined walls, trapezoidal doorways, beveled corners and flexible joints, all designed to absorb and dissipate seismic energy. When a powerful earthquake hits these structures, the upper sections tend to collapse, while the megalithic foundations, made of the heaviest blocks, remain standing. Paradoxically, it is these colossal stones that provide the stability the smaller masonry lacks. At the archaeological site itself, one striking detail stands out. Even some of the largest stones appear to have been violently fractured. abruptly separated and scattered almost randomly across the terrain. And it doesn't stop there. We see monumental blocks surrounded by small, poorly fitted stones, placed later as improvised patches. Many of these giant monoliths feature unusual cuts and shapes, as if they once served as bases or supports for structures that no longer exist. There are also recesses and cavities on their surfaces, which some interpret as features to facilitate transportation. But this raises another question. Why do only some stones bear these marks, while most do not? These carvings may have served multiple purposes: leverage points for lifting, anchor areas for ropes, or joints to lock adjacent pieces in place. In various ancient quarries around the world, small protrusions, known as bosses, were intentionally left to help maneuver the block without damaging the finished face, later to be removed. In a site that was reoccupied and reshaped over centuries, it is natural to find blocks of different ages, styles, and functions coexisting side by side. Despite all this, there is still a lack of full-scale demonstrations showing how blocks weighing dozens of tons could have been hauled uphill using only the tools supposedly available at the time. And here enters an intriguing point. Modern experiments, carried out both in Peru and in other countries, have already succeeded in moving rocks weighing between 10 and 30 tons using wooden sleds, natural fiber ropes, compacted earth ramps, and even water as a lubricant. The results are consistent. The better prepared the ground, the less effort required. The longer and gentler the ramp, the greater the safety during transport. If we scale this up to blocks weighing 50 or 80 tons, there's no need to invoke mysterious forces. What is required is more time, more people involved, and above all, more space to build long ramps. In the book Fingerprints of the Gods, Graham Hancock cites an episode described around 5 centuries ago by Garcilaso de la Vega in his work The Royal Commentaries of the Incas. According to the chronicler, there was an attempt to transport a massive stone block uphill in order to restore part of Sacsayhuamán. The account mentions about 20,000 men involved in this monumental effort, but the endeavor ended in tragedy. The stone is said to have fallen, killing approximately 3,000 people. It is evident that such grandiose numbers may have been exaggerated or distorted over time, as often happens in many oral traditions. Even so, the mere record of this event suggests that something catastrophic really did occur, which reinforces the importance of seriously assessing the technical challenges involved in this type of construction. That's why, when we talk about modern theories on how these blocks were moved, proposing ideas is not enough. It is essential to test them. Formulating hypotheses is relatively simple, but proving them in practice is another story. And that is precisely the point. When some insist that ropes, logs, and brute force were enough to move stones weighing dozens of tons uphill, what is lacking are replicable experiments at significant scale and under controlled conditions that demonstrate the viability of this method. Even if such experiments are carried out, we would still not have answers to all the enigmas. After all, similar mysteries remain scattered across the world, from the Colossi of Baalbek in Lebanon to the monuments of ancient Egypt, not to mention the 125-ton stone of Sacsayhuamán mentioned earlier. And this is exactly where you come in. What do you think about all this? How do you believe these colossal blocks were actually moved and positioned? And what is your view on the so-called Temple of the Sun, which rises at the top of Ollantaytambo? What we can say for now is that moving megablocks did not rely solely on physical strength. It involved logistical planning, mastery of friction, careful preparation of the terrain, and above all, time and coordination. But the topic remains open, awaiting new discoveries and evidence. That's all for today. Thank you very much for watching, and don't forget to leave your thoughts in the comments.